Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Today we are talking about trapezoids and kites. So go ahead and take a moment and get all of that written down. Unit 3, Lesson 6, trapezoids and kites. That's what we're working on today. And then once you have that down, go ahead and flip to a new page. And you're going to notice that I already have quite a lot written today. So I need for you to take a moment and get all of this down. So whatever today's date is for you, this is Unit 3, Lesson 6, the essential question, what are the important properties of kites and trapezoids? So what I thought I would do today, instead of talking about all of these, is give you a moment to just write them all down. What you see in blue, these are the properties. And so I should probably add over here, these are the properties. And then in red, I wrote the definitions. And in retrospect, I probably should have put the definitions first and then the properties. So if you want to do that, you certainly can. But go ahead and write them down. They're not going to make a whole lot of sense until we work with them a little bit. But at this point, pause the video, get all of this down, and then go ahead and push play again when you're ready. Okay. So we're going to draw each of these. A kite is a quadrilateral with two pairs of consecutive congruent sides. And if you've ever flown a kite, you probably know what one looks like, although now they make crazy kinds of kites. But a kite is a quadrilateral, 4 sides, with 2 pairs of consecutive congruent sides. So I'm going to show you how to draw one. We're going to start by just identifying one of our points. And then we'll create a second point sort of out here. I'm going to go down 2 spaces and 3 spaces to the right. And that will be one of my sides. So I need 2 pairs of consecutive congruent sides. So I'm going to make a side right next to this that's exactly the same length. And the easiest way to do that is to, again, go sort of up 2 and over 3 or down 2 and over 3. So if I put it right there and make it nice and symmetric, these line segments will be the same length, right? That one and that one. And we can show that by putting tick marks. So that's a pair of consecutive congruent sides. They're next to each other, that means consecutive, and they're congruent, the same length. And so my other 2 sides have to be congruent to each other, but they can't be congruent to these. If they're congruent to these, I have a rhombus. So I need them to be different length, but the same length as each other. So what I'm going to do is find sort of the middle point, and I'm just going to come out farther. Really, I'm just going to make it as big as I can make it, put it way out there. And if I connect this and this, these sides will be congruent. So I've just made another pair of consecutive congruent sides. These 2 sides are next to each other, and they're congruent. So one pair of consecutive congruent sides, another pair of consecutive congruent sides, and that is a kite. So what we're going to do, this is just the definition. I'm going to go through and talk about each property and label it on the kite. So first of all, the diagonals are perpendicular. And so I'm going to take a moment and draw in the diagonals. And I'm going to use dashed lines to show the diagonals here, but you can do it however you want. Okay, those are my diagonals. And you can see very clearly here that they're perpendicular. They fall on grid lines. But in any kite, they're going to be perpendicular. So that's my first property right there. The second property is that one pair of angles is congruent. And so that's really important in a kite. I hope you can see that these angles, this one and this one, are not the same. This angle is bigger than this angle. But these 2 angles are congruent. And so you're always going to have in a kite exactly one pair of angles that's congruent. So those, I think I'll use 2 loops. Those angles are congruent, and that's the second property. The third property says one diagonal is bisected. That means one of these diagonals was cut exactly in half. And you can clearly see here that this diagonal was not cut in half. This piece is way longer than this piece, but this diagonal was cut in half. So I'm going to have to use 3 tick marks here because I already used up my 1 and 2 tick marks. So this little piece is congruent to this little piece. That's the third property. And the fourth property is that the non-congruent angles are bisected by a diagonal. These angles are congruent, but the other ones, they're not equal to each other, but they're cut into 2 equal pieces. So in other words, this angle right here is congruent to that angle. Okay, this angle was bisected. And then this angle was also bisected. So I'm going to have to use 3 loops. That angle and that angle are congruent. So that's a lot of stuff to fit on your kite. Hopefully you got it done. But the definition is that these are congruent and these are congruent, and everything else on here is just a property of the kite. Let's talk about a trapezoid. So I should first say that we're really only going to be focused on isosceles trapezoids. A trapezoid is any quadrilateral with one set of parallel sides, but in an isosceles trapezoid, you have a quadrilateral with one pair of parallel sides, and those are called the bases, with the other sides, which are the legs, being congruent to each other. So I'm going to show you how to build that. On your paper, I think we'll start with a fairly long side, so I'm just going to make it as big as I can. The bigger we make it, the easier it's going to be to show all of the properties. So mine is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And so I'm going to build another side that's parallel to this because that's the definition of a trapezoid. And so I think just to make sure that I get it all in, I really want this to be as big as possible. So from here I'm going to go maybe down 4 and over 2 to put another point. And then from this side I'm going to do the same thing. I'm going to go down 4 and in 2. If I went the other way, I would have built a parallelogram. Okay, so in a trapezoid you just have one set of parallel sides. So what this does is it creates a quadrilateral where these sides are parallel, so let's flag that. Those sides are parallel. And the other sides, which are called the legs, are congruent to each other. And I made it that way because I went down 4 and over 2, down 4 and over 2. So they're the same length. Remember, this means parallel, this means congruent. And we do need to label, this is called the base. This is the other base, so the bases are parallel. And then the other 2 sides are called the legs. So leg, leg. Oh my goodness. Okay. So let's go through, and just like we did with the kite, we are going to mark all the properties. So the first property is that we have 2 pairs of congruent angles. And so here we have, I'll use red again. Here we have 1 pair of congruent angles. Those are congruent. And then the acute angles will also be congruent to each other. All right. The second property is that the diagonals are congruent. So again, I'm going to draw in my diagonals. And this only applies to isosceles triangles. So this diagonal and this diagonal are congruent. So it's a little hard to mark that. I'm going to mark that this is congruent to this, but be aware it's the entire diagonal, not just that one piece. And then our third property is that the non-congruent angles are supplementary. So it's a little bit difficult to mark it on the diagram, but if you take the 2 angles that aren't congruent to each other, so that's this angle and that angle, they have a sum of 180 degrees. And the same is true over here. These 2 have a sum of 180 degrees. So you've got some congruent angles. These are congruent. These are congruent. If they're not congruent, then they add up to 180. So those are the important properties of kites and isosceles trapezoids. And we're just going to do a couple of quick examples here, and then we'll be done. Okay. Boy, I'm having issues. All right, example 1. We're going to draw a kite. And you can try to make yours look like mine, or you can make your own kite. It doesn't really matter. Try to make it at least sort of the same shape as mine. All right, there's a kite. We're going to label the vertices A, B, C, D. We're going to draw in the diagonals. We are going to label this 32 degrees. This is 62 degrees. And there are 2 things I want you to do. Part A, I want to know what is the measure of angle CBE. And then part B, I would like to know the measure of angle ABE. Okay, that's it. So let's start with the measure of angle CBE. The first thing we need to do is locate it. So I forgot to put E. This is E. Okay. CBE, the vertex is at B here, and it goes out to C on one side and E on the other side. So we're talking about this angle CBE. So to find that angle, the property of the kites that's really important here is that the diagonals are perpendicular. So you should know that this is a 90-degree angle. So that makes this problem really pretty simple because we have a right triangle, we have a 62-degree angle, a 90-degree angle, and we need to find the third one. So at this point, the video is going to pause. I'd like for you to find the measure of that angle and then enter it in, please. Okay, hopefully you figured out that you just need to do 180 minus 90, not minus 90, minus 62. And hopefully, if I'm doing my mental math right, that's 28 degrees. Part B, find the measure of angle ABE. So ABE would be this angle here. And this is a really similar process. I'm not even going to make you do it on your own because it's pretty simple. This is also a 90-degree angle because in a kite, the diagonals are perpendicular. So we just need to do 180 minus 90 minus 32. And I think that's 58 degrees, so I'm doing it in my head. So hopefully I got it right, 58 degrees. Okay. Pretty simple. I could throw lots of different questions at you about kites because we really have 4 right triangles. So I could ask you Pythagorean theorem questions. I could give you an expression here and an expression here, and you should know that those sides are equal, so you could set them equal and solve for x. So there are lots of different problems that you might see about kites. The important thing to remember is that whenever you see a problem, refer back to your properties, figure out which one is helpful for you, and use that to solve the problem. Okay, we are going to do one more example. Some nice music for you. I hope you enjoyed the musical interlude. The bell's going to ring in a minute. Okay. So here's a trapezoid. Hopefully you got that copied down while you were enjoying those smooth jams. And what we're going to try to do here is find the measure of angle C. Remember, when we're looking for the measure of an angle, I'm looking for a number, so a certain number of degrees. So for this problem, we need to think back to what are the properties of isosceles trapezoids, and I really should have told you that these sides are congruent. So this is an isosceles trapezoid. So if we look back at our properties, what we have here are two angles. So it says here that we have two pairs of congruent angles. It also says the non-congruent angles are supplementary. So what we need to do here is figure out these two angles. Should they add up to 180 or should they be equal to each other? And I hope you can see that these are acute angles here. They're both less than 90 degrees. These are obtuse angles. They're both more than 180 degrees. And so, or sorry, more than 90 degrees. So I hope you can see that these two cannot possibly be supplementary, so they have to be congruent. They have to be equal to each other. And so the way to begin this problem is to solve for x. Once we solve for x, we can find the measure of these angles. Once we know those, we can find the measure of angle C. So we're going to begin by saying 2x plus 21 has to equal 3x minus 4. Go ahead and solve it on your own paper while I do it up here. I'm going to give you a head start. Okay, so I did a couple steps here at once, but I got that x equals 25. So we're not even close to done. We don't know any angle measures. All we know is that the value of x is 25. And so our next step is to choose one of these and plug in 25 for x. And you can use whichever one looks easiest to you. I prefer addition to subtraction, so I think I'll use this top one. And so I'm going to show my work really clearly and say the measure of angle A equals 2x plus 21, and then I'm going to replace the x with 25. You guys go ahead and do it on your own paper. Okay, so the measure of angle A is 71 degrees, and once you know something about a figure, you should just go ahead and mark it on your diagram because it'll probably come in helpful. And we better get 71 here if we plug 25 in for this x. And we do a quick check. 3 times 25 is 75, minus 4 is 71. These angles are supposed to be congruent, so we ought to get the same thing. So to find the measure of angle C, we just need to use that third property, which says that the non-congruent angles, so like this one and this one, they're not congruent, they have to be supplementary. So in other words, 71 plus the measure of angle C has to equal 180 degrees. And so to finish this up, all we really need to do is subtract 71 from 180. And we get 109 degrees. So the measure of angle C is 109 degrees. So that's it for today. I'd like you to go ahead and write a summary. If you prefer to just type it in, that's fine. If you like writing it in your notebook first, go ahead and do that. Submit your summary, and then you're done.